My name is Antaki. I'm an ophthalmology resident at the University of Montreal. And today my project is called Fully Immersive Virtual Reality Simulator to Improve Retinal Surgery Training. I have no relevant financial disclosures. When David Kasner and Robert McAmer laid the foundations of modern vitrectomy in the 1970s, little did they know that vitrectomy would become the standard of care for many vitreoretinal diseases. And today, pars plana vitrectomy is considered a fundamental skill in vitreoretinal surgery education. Many fellowships rely on the Halstead apprenticeship approach of see one, do one, teach one. However, we believe that technology can supplement this model. See one, simulate one, do one, teach one. I'm here today because we are seeking $35,000 to build a virtual reality simulator that teaches vitrectomy. The simulator will be fully immersive, portable, and affordable. Immersive virtual reality simulation offers a low-risk environment for learning and has been extensively employed in the military and in the aviation industry. Ophthalmic education is no stranger to virtual reality, thanks to the IC simulator with its anterior segment and vitrectomy modules. The first time I saw an IC simulator was on board of the Orbis Flying Eye Hospital that I visited with my ophthalmologist father when I was a teenager in 2008. The plane was visiting my hometown Aleppo in Syria to train the local doctors improve vision care in the region. Looking back at this moment, I now realize that as soon as the plane took off, the local doctors could no longer train using simulation. And this is because the IC has a very high purchase price at around $150,000, limiting its worldwide adoption for most countries in pink and red on this map. The size and the weight of the IC are limiting factors for accessibility and mobility, and only one trainee can use the simulator at a given time. So we aim to build a software that will be compatible with commercially available off-the-shelf virtual reality headsets like the HTC Vive, the Oculus Quest, or the Microsoft HoloLens. And we will leverage on the powerful processors, connectivity tools, and cameras of those VR headsets. Our virtual instruments will be controlled either using hand tracking, touch haptic devices, or built-in touch controllers. We project to have a variety of setups, including a workstation setup and a home setup for at-home learning. Dr. Karim Hammamji and I have partnered with the Research Laboratory for Computer Graphics and Virtual Augmented Reality of Polytechnique Montréal under the supervision of Dr. Benoit Ozel and his master student, Mr. Cédric Doucet, who will dedicate the next 2 years for this project. Our study will be carried out in 2 phases. Over the next 18 months, we will develop the simulator through iterative feedback and regular meetings with our engineering team. And then we will validate the simulator over a period of 9 months where we're going to prove construct validity and skill transfer. We will initially focus on 4 training modules: navigation training, tremor control, laser precision, and forceps control. Navigation training simulates core vitrectomy and PVD induction, and here trainees will learn how to perform efficient and safe movements in the vitreous cavity. They will be asked, for example, to move the tip of the vitrector to define targets in the vitreous, and we will introduce levels of difficulty by using targets with varying sizes, locations, and introducing gravity. Tremor control will simulate peripheral shaving, and here trainees will learn how to perform accurate and safe movements in the peripheral retina. They will be asked to move the vitrector inside a specific precision boundary. We will introduce levels of difficulty by using nonlinear trajectories and narrow precision boundaries. Laser precision will simulate endolaser, and here trainees will learn how to perform safe endolaser around retinal breaks. We will introduce levels of difficulty by using multiple breaks in the same patient, using difficult to access target areas and small breaks. Forceps control will simulate membrane peeling, and here trainees will learn how to perform safe ERM or ILM peeling without damaging the underlying retina. They will learn how to use forceps to grip and peel those membranes, and we will introduce levels of difficulty by using highly adherent or unstained membranes. 2 prospective controlled interventional trials will be carried out for validation. First, to prove construct validity, we will collect information on personal and environmental presence during simulation to know how realistic our simulator is. We will compare the scores of 2 groups, a group of novice residents and a group of vitreoretinal surgeons, and we expect the vitreoretinal surgeons to perform better using our simulator. And for this, we will recruit approximately 10 participants for each group. Skill transfer will be carried out by assessing the transfer to the validated simulator like the IC. Current guidelines recommend doing that before assessing skill transfer to the operating room. We will compare the scores of 2 groups, a group that pre-trained using our simulator and a group that has never trained using simulation. We will compare their scores on the IC simulator, and we expect the group that pre-trained to do better. And for this project, we will recruit 10 junior residents or senior medical students per group. Our budget justifies the $35,000 we are seeking. Some of the money will be used to pay for personnel, but most of the money will be used to pay for the VR headsets, the haptic feedback devices, and the virtual reality workstation. With your funding and together, we will improve access to retinal surgery training. And we hope that in the future, this platform would become a tool not only for trainees, but also for established vitreoretinal surgeons who would like to learn new techniques at home. Thank you.
Good. If you could unshare, thank you very much, Dr. Antaki, for a very clear and timed, perfect presentation. At this time, I invite the lions to sink their claws into you and tear you apart. Go ahead, guys.
So I'm going to start.
Sorry, go ahead, Mark. Go ahead.
So congrats for a great presentation and very innovative idea, Dr. Antaki. What will be the cost on average for the hardware and the software for someone in the future to acquire these tools?
So over the next 18 months, we will try different tools. So in case our simulator requires touch haptic devices that need to be bought, that are, by the way, commercially available, we estimate the cost to be around $7,000 because there's cost for hardware. However, if we're able to use hand tracking as instruments simply with a VR headset, then the cost can be as cheap as $500. And there's one important thing to remember, that if trainees decide to buy their own VR headsets, then they can use them for other things. They can use them for gaming. They can use them to exercise. So what we're building is really the software, and the software wouldn't cost much because we're going to spend the $35,000 developing it.
Faraz, my question was exactly what Mark just asked you, but as you were speaking, I thought of another question. Can you use this technology to train people in other parts of ophthalmology, for example, cataract surgery?
Yes. So currently, looking at the market, there is a company that's looking at at-home training for cataract surgery. So our main focus at this time is vitreoretinal surgery, but the opportunities are immense. And once the platform is set up, then we can even teach, as I said at the end, established doctors new techniques like port delivery systems or things like that.
So Faraz,
good, David, good.
Hey, he's waiting for me to jump in there, I think. So Faraz, you may or may not know, but when IC first came to Canada, we had the first IC in Canada, and we did a whole bunch of studies on it, and we tried to test validity, and some of those studies have been published. We have another study coming out shortly in Ophthalmology Science on a number of variables on the IC simulator. Do you foresee what you have just presented to us replacing the IC simulator? Or are you looking at this as a different form of education that's complementary to the IC? And I got a second question, but I want to hear what your answer is first before I follow to ask you the second part of that.
At this current stage, we're using the IC as our benchmark. So in the future, it could replace the IC in some parts of the world. However, the IC provides some benefits, including the use of a microscope, and what it does really well is simulate the instruments. So in centers that can afford the IC is still a great choice. We think that our simulator has the potential to become as good, and we think in some areas, if we're looking at group teaching, even in North America, could be useful. So you can teach multiple people at the same time using our simulator.
So you just highlighted something I was going to jump on in this format of what you're developing. Is so much of what retina surgery is about is dependent on the instrumentation. And so, you know, many of us on this call, the Lions and Lionesses have trained fellows for 20 years. And as we watch them go through the learning curve of learning a vitrectomy, so much of what they end up struggling with is, you know, what does a cutter feel like in your hand? How far can you put a light pipe into the eye and be safe and get away with it? You know, what happens if you're distracted on an instrument exchange with your light pipe? And so a large part of being a great retina surgeon is learning to use the instrumentation that are core to our procedures. And if you can help a student get comfortable with either a light pipe, a forceps, or a cutter, you're advancing them to the point where when I now have to let them do the real thing in a real human being, they're going to be way better off. What I worry a little bit about is that the haptic devices and the things you showed me are not really true mimics for what we would be doing in a real vitrectomy procedure. And, you know, people with tremors, right? Those haptic devices you're showing there, that won't resonate. You won't see a tremor, you know, that. And the tasks you've chosen there are very much, they're basically the same tasks on the IC, all right? I noticed that when you presented that. So you're presenting us the same tasks you're going to do on IC. I would challenge you to think bigger with this. I think this is a very ambitious project. I think it's a great project, an amazing project. So I compliment you on thinking big, but I would challenge you to understand that I think if you restrict yourself to some of the ways you're going to test on this device, it may not resonate and it may not project forward to do what I think you want it to do, which is to smooth the transition from ophthalmology resident into a fairly competent beginning retina surgeon.
Thank you, Dr. Chow. And that's why we're dedicating 18 months to work with our engineering team to try different things. So with our vitreoretinal surgeons, we will try those things, and we're really open to trying different tools, different instruments to see what best simulates real life. So we're giving this time, and you know, we're open for feedback, and you know, I'm thankful for your opinion.
Dr. Tennant, good. Yeah. Last swipe, he's still alive.
Well, I have a suggestion. So, you know how popular gaming is these days online? I would suggest vitreoretinal surgery gaming. So you have the ability to produce multiple different platforms at the same time to be doing virtual surgery. And so you could do this in a competitive fashion all across the country, internationally. And so you could have forums at meetings where you have people competing against. I know David Chow, I've seen his hands in action. They're amazing. Would he be the greatest surgeon, or would there be someone else who could do that work as effectively? Well, Michael, I haven't seen you operate. You probably could. I don't know.
I had to do that for David. Sorry.
That's a great idea, Dr. Tennant. And it is true that with today's social media, introducing this aspect would be really, really interesting. And we will definitely be looking into that over the next 18 months.
Fantastic.
Thank you.
Thank you very much for the presentation and for fielding the questions. And the first prize, therefore, goes to the same individual that the audience voted for for an outstanding presentation with terrific potential and well-fielded questions. Congratulations, Dr. Faris Antaki.
Thank you so much.
Congrats, Faris.
Congratulations to the three of you. Very nice work. Very, very nice work.
Thank you. It's a great honor to get this prize, and we won't disappoint.